So, I want you to picture an ant, just a regular ant, sitting right in the middle of a standard flat piece of paper.
Okay, I'm picturing it.
Now, here's the riddle for you. If that ant is, like, entirely forbidden from turning over the edge of the paper, and it absolutely cannot bite a hole through the surface, how does it effortlessly climb from the front of the paper to the back?
Right. Well, for a conventional thinker, that's just an immediate dead end. I mean, you look at the physical constraints, the rigid two-dimensional geometry of a flat page, and you just confidently declare it impossible.
Yeah, the ant is trapped.
Exactly. But it's not actually impossible. It just requires you to, stop looking at the ant and start looking at the paper.
Which is such a mind-bending way to frame it.
Yeah, it was the German mathematician August Ferdinand Möbius who solved this exact conceptual puzzle. You take that same strip of paper, give one end a precise 180-degree twist, and connect it to the other end.
And you create a Möbius strip?
Right. Suddenly, the front and the back of the paper are just one continuous looping surface, so the ant can crawl literally everywhere without ever crossing an edge or making a hole.
Okay, let's unpack this, because that Möbius strip is the foundational metaphor for our deep dive today. We are pulling from a really fascinating essay titled Talking About the Möbius Strip by Schiffing.
Translated by Kinyu and edited by Peter, yeah.
Right. And our mission today is to completely rewire how you, the listener, approach the impossible problems in your life. We're going to explore the radical difference between conventional thinking, which, keeps you trapped on one side of the paper, and unconventional thinking.
Which bends the environment itself.
Right.
Because what we so often deem impossible is really just a failure of imagination.
Yeah, changing the fundamental shape of a problem often makes the solution effortless.
Exactly.
And while a paper loop is like a neat physical trick, this essay takes that 180-degree twist and applies it to everything. I mean, human culture, history, even the fundamental laws of physics.
It's a huge leap, but it makes so much sense.
Right. Let's start with how we build these flat pages in our own societies. The essay brings up a legendary story from the literary work Flowers in the Mirror about Empress Wu's Zetian.
Oh, yeah. It's a brilliant example of audacity. The Empress issues a command to nature itself, ordering all the flowers in her royal gardens to bloom overnight.
Which sounds insane.
Completely. The decree essentially says, don't wait for the morning wind to push you. Blossom now.
Now, basic botany and conventional wisdom tell us that in the bitter cold of winter, only winter plums are going to survive, let alone bloom. Everything else should just be dormant, withered branches.
Right. You don't just yell at a freezing garden and expect spring.
But by demanding the impossible, by stepping completely outside the boundaries of conventional expectation, the story claims she actually forced the Confang and Shanglin gardens to bloom overnight.
Yeah. Everything blossomed except the peonies, apparently. It's basically a metaphor for how reality sometimes bends to sheer unconventional will.
It's a striking image, but, we don't have to be ancient royalty ordering flowers around to see this clash of paradigms. We actually stumble over our own rigid, conventional thinking every single day.
Oh, constantly, often without even noticing. What's fascinating here is how the essay highlights that what feels like an absolute undeniable logic to one group of people is completely unnatural to another.
Give an example of that.
Well, take something as mundane as writing a mailing address.
Yes. This blew my mind because it's just so incredibly ordinary.
Right. So if you look at the British or American convention, the logic is to zoom in. You start with the hyper-specific and work your way out to the general.
Right, like 38 Cosbill Street, Columbia District, New York City, United States.
Exactly. Start at the front door of the house and end up at the nation. But the Chinese convention does the exact opposite. They zoom out to in.
Meaning they start big.
Yeah. The exact same address is written, United States, New York City, Columbia District, Cosbill Street, number 38. They start with a massive entity and narrow down to the door.
It is the exact same geographical data, but the mental framework used to process reality is completely reversed.
Completely reversed.
To me, it's like directing a movie. Do you start with a sweeping, wide-angled drone shot of the entire country and slowly push in until you see the actor's eye? Or do you start with an extreme close-up of the eye and pull back to reveal the world?
That's a great way to visualize it. Neither is objectively more true than the other. It's just a framing choice.
But if you're used to the close-up, the wide shot feels like you're walking backward. So think about how many daily frustrations you face in your workplace or in relationships that are just a clash of a dress order.
Yeah, and if we connect this to the bigger picture, it reveals a really profound truth about human behavior. The essay pushes this into our core beliefs, too. contrasting how different cultures view grief.
Oh, the funeral example.
Right. Conventionally, in many Western societies, death equals black clothing and crying. That is the accepted truth of mourning.
But elsewhere, grief is expressed through laughter or by wearing pure white to show respect.
Exactly. Even the point of being alive at all is up for debate. The secular world generally agrees that human beings are born to pursue happiness and enjoyment.
Right, the pursuit of happiness.
But many religious frameworks, like Buddhism, start from the exact opposite premise. You are born to suffer, and life is about transcending that suffering.
And that is the ultimate takeaway from these cultural examples. Unconventional thinking doesn't just mean being a contrarian for the sake of it.
No, not at all.
It requires the deep realization that our conventional rules are rarely laws of nature. They are just agreed upon illusions, habits of mind.
They're the flat paper.
Exactly. Now, I can entirely buy that cultural traditions and formatting an envelope are agreed upon illusions. But what happens when we look at science?
Science.
Because science isn't a habit of mind. It's supposed to be the rigid, unbending truth of the universe.
Well, the essay argues that the history of science is essentially a massive graveyard of conventional thinking that got completely obliterated by unconventional leaps.
So every major scientific breakthrough is basically a Möbius strip moment.
Precisely. Consider aerodynamics. For centuries, conventional observation dictated a very simple, seemingly unbreakable rule. Light things, like chicken feathers, can float in the air. Heavy things, like solid iron blocks, cannot.
Which makes total sense. You drop an anvil, it falls. You drop a feather, it drifts.
But then someone looked at the shape of a bird's wing and realized that if you manipulate the flow of air, you can create a pressure difference. You create lift.
And suddenly, the impossible becomes mundane.
Exactly. Today, iron blocks weighing tens of thousands of pounds are flying across the sky every single minute. The weight wasn't the limiting factor at all. The shape of the surface was.
That's wild. And this same demolition of the rules happened in mathematics too, right?
Oh, math is full of these structural collapses. There was a long period where the absolute rule of mathematics was that any valid number could be neatly expressed as a ratio of two integers.
Like a clean fraction.
Right. But then, mathematicians proved the existence of irrational numbers, like pi or the square root of 2, numbers that go on forever without repeating.
It must have been terrifying for them. I mean, imagine having a ruler where certain physical lengths just cannot be measured by your system. It broke the assumption of a perfectly neat universe.
It caused absolute chaos in ancient Greece. And then later, when real numbers were finally accepted, mathematicians theorized imaginary numbers.
Like the square root of a negative one.
Exactly. Conventionally, you cannot multiply a number by itself and get a negative. It shouldn't exist. The essay describes them as ethereal and deeply confusing.
Well, we use them now.
We have to. Today, without those imaginary numbers, we couldn't calculate alternating electrical currents. We wouldn't have modern electronics.
So the impossible math actually runs the real world.
It really does. And physics experienced an even bigger paradigm shift. Traditional physics viewed space as an absolute, rigid box. Matter bounced around inside the box, and time was just a separate, invisible clock ticking evenly in the background for everyone.
But Einstein comes along and completely warps the box. Space and time aren't a stage. They are a fabric. And that fabric curves and stretches depending on how much mass is sitting on it.
Which brings us back to the mathematics of twisting fabrics, topology. Topology is the study of geometric properties that don't change when you stretch or twist an object.
Like turning our paper into a Möbius strip.
Exactly. And the essay uses topology to pose a fantastic riddle. How can a person enter a perfectly sealed, windowless, doorless room and then exit it without breaking a wall?
Conventionally, it's a locked vault. You can't.
But through topology, the essay argues, it's entirely possible. If you think of that sealed room not as a rigid box, but as a circle drawn on a flexible sheet of space-time, you don't need to break the line of the circle.
You just fold it.
Right. You fold the entire sheet through a higher dimension so that the outside touches the inside. The boundary is bypassed completely.
Meaning you step through the folded space, not the wall.
Yeah.
And the essay takes this even further into invisibility, which conventionally human invisibility is just comic book magic.
Of course.
But the essay frames it logically. It says we see objects because light bounces off them into our eyes. So if you can locally distort the space-time around a person, you bend the light entirely around them.
Like water flowing around a rock in a stream.
Exactly. The visual information bypasses the object. Boom. invisibility.
And if we accept that the very fabric of space and time can be folded and distorted like that, it drastically shifts our perception of humanity's ultimate limits.
Yeah, it really does.
The essay pivots from theoretical physics to our most daunting physical hurdle, which is space exploration.
Right, because if you look at all the probes and telescopes we build, mankind's subconscious goal is obvious. We are desperately looking for a new, habitable star system.
But conventional science delivers a pretty brutal reality check. Earth's immediate neighbors are toxic or dead, and the nearest potentially habitable stars are tens of light years away.
Which leads conventional thinkers to conclude that humanity is stuck here. We have one Earth, and due to our short lifespans and the vast distances, leaving the solar system is fundamentally impossible.
But the essay flat out rejects this. It says impossible, absolutely impossible, meaning it is impossible that the universe designed us to be permanently trapped.
So how does the author get around that?
By challenging the ultimate speed limit of the universe. Einstein established that the speed of light is the absolute cap for the movement of matter. As an object with mass approaches light speed, it requires infinite energy.
Right.
But the essay argues Einstein's limit only applies to physical mass. What about the speed of non-material movement?
Wait, like information or quantum states?
Exactly. The essay calls this a negative cosmic speed. If you stop trying to push a heavy physical rocket through space and instead look at how non-material sequences or wave states can bypass conventional spacetime, perhaps through quantum entanglement or topological folds, instant travel across tens of light years ceases to be a fantasy.
That is wild. And speaking of the quantum realm, the essay completely flips the script on the famous Heisenberg uncertainty principle.
Oh, this part is fascinating.
Yeah, conventionally, the uncertainty principle says you can't measure a subatomic particle's exact position and its exact speed at the same time.
Right. The traditional explanation is the observer effect. Imagine trying to figure out where a billiard ball is in a pitch-black room by throwing other billiard balls at it.
You would hit it, right?
Exactly. The very act of hitting it to find its position knocks it off its current path, changing its speed. We assume the particle's state is inherently fuzzy and disturbed by infinite microscopic forces.
But the essay looks at this and says, no, the universe isn't fuzzy or random. The universe is perfectly orderly. The uncertainty principle isn't a fundamental rule of reality. It's just a reflection of our current ignorance.
Yeah, the author's saying if we actually had the computational power to map every single one of those infinite microscopic forces, every collision, every variable, we absolutely could calculate both speed and position.
It's not magic. Our tools are just too blunt right now.
And this raises an important question that the essay lingers on. Are we actually getting smarter, or are we just getting bogged down?
What do you mean?
Well, the author points out that a century ago, a brilliant 20-year-old could realistically absorb the sum total of human scientific knowledge. They could reach the frontier of understanding while their brain was still young and flexible.
But today, the sheer volume of data is crushing. I mean, a 30-year-old could spend their entire life studying just one tiny subfield of quantum mechanics and still not know everything.
Exactly. We are hitting a wall simply because the backpack of accumulated human knowledge has become too heavy to carry.
We are exhausted before we even reach the boundary of the unknown.
Yeah.
Here's where it gets really interesting, though. Because the essay takes this massive abstract idea of calculating infinite quantum variables and points it right at you, the listener.
The fate prediction stuff.
Yes. If human beings are ultimately just incredibly complex collections of particles, then our lives seem to fall under that same illusion of uncertainty. We think our blessings, our illnesses, our financial ruin, or our success are just random luck.
But if the universe is orderly, as the essay insists, then your life has a fixed, calculable trajectory. Right. If a superintelligence could analyze the hundreds of millions of microvariables affecting your genetics, your environment, the physics of your daily interactions, it could uncover the exact laws governing your existence.
It implies that with enough data, someone could accurately measure your entire life. They could map out your prosperity, predict your illnesses, and calculate the exact day you will die. The randomness of human destiny is just another flat piece of paper we haven't learned to fold yet.
It's a staggering philosophical shift. But if we are just complex structural algorithms that can theoretically be calculated, what is keeping us so firmly stuck on this rock?
Right.
This brings the essay to the most immediate physical constraints of the human body. which are gravity and distance.
Yeah, if we want to travel the stars, we have to deal with gravity. Conventional thinking, handed down by Isaac Newton, says gravity is a universal constant. It's everywhere. Mass attracts mass, and we are heavily tethered to the Earth. You can't just float into the sky without a rocket.
But the essay proposes a deeply unconventional rewrite of physics. It argues that gravity is not an intrinsic property of mass, but rather gravity is generated entirely by motion.
Okay, explain the mechanics of that, because it sounds totally counterintuitive.
The premise is that large motion equals large gravity, and small motion equals small gravity. Therefore, if an object experiences absolutely zero motion, it generates zero gravitation. And without gravitation, there is no weight.
Okay, I have to push back here. The Earth is hurtling through space at roughly 2.5 million kilometers a day. The solar system is orbiting the galactic center. Nothing is ever standing still. So how can zero motion even exist?
The essay counters this by leaning heavily into relative motion. Imagine you are sitting in a windowless cabin on a massive cruise ship sailing on a perfectly calm sea.
Okay.
If you drop an apple, it falls straight down. You feel absolutely no sensation of forward movement. Relative to you and the apple, the ship is stationary, even though it's moving at 20 knots.
We experience that every day. We don't feel the Earth spinning while we drink our coffee.
Exactly. So extrapolate that into space. Imagine two massive objects flying in the exact same direction at the exact same speed. Relatively speaking, between those two specific objects, there is zero motion. They are completely stationary relative to one another.
Wow, okay.
And according to the essay's framework, zero relative motion means zero relative gravity between them.
So if you placed a human being perfectly sandwiched between those two synced objects, that person would lose all weight. They would be in a pocket of zero gravity, able to fly freely, completely decoupled from the universal tether.
It's a radical thought experiment that completely redefines physical constraints. And it perfectly sets the stage for the essay's most shocking proposal, teleportation, or, as the author brilliantly calls it, faxing a human being.
I love that terminology. The essay asks a very blunt question. We can fax documents, we can email complex data instantly, and we know cloning technology is real, so why can't we fax a person?
Right. To understand the how, the essay asks us to reconsider what matter actually is. Ultimately, biological matter is just a sequence of molecular structures.
Okay, but the essay uses an example here that I found completely wild. It claims that if you were to somehow arrange a pig's genetic structure into the exact structural sequence of a human being, that pig would suddenly be able to speak human language.
Yeah, that's a big claim.
I have to call a timeout. That sounds like B-movie science fiction. You can't just scramble a pig's DNA and get a talking animal.
It sounds absurd if you are clinging to the biological specifics, but look at the underlying structural metaphor the author is making. Think of it like a musical instrument.
Okay.
A piano and a violin are completely different physical materials,
Yeah.
different genetics, so to speak. But if they play the exact same sheet music, the structural sequence of the song is identical.
Yeah.
The essay is arguing that the sequence is what matters, not the meat.
So it's like making a phone call. When I call someone in London, my physical vocal cords aren't traveling through a transatlantic cable.
Exactly. The microphone translates the structure of your voice, the exact sequence of frequencies and amplitudes, into data. That data travels at light speed, and the speaker on the other end uses local energy to perfectly reconstruct the structure of your voice.
So applying this to human teleportation, the essay suggests that using that negative cosmic speed we discussed earlier, we don't need to load a physical body onto a rocket.
Right, no heavy lifting.
We just scan the exact molecular and quantum sequence of a person. We fax that structural data across millions of light years to a receiver on a distant planet.
And once that data arrives, the receiver uses local energy on that planet to physically reconstruct the sequence. Essentially, a hyper-advanced clone is generated instantly. A new you steps out on another star system.
But the age-old sci-fi question remains, is that really you? Or did you just die on Earth and a copy woke up over there?
The essay is definitive on this. Yes, it is fundamentally you. Because conventional thinking assumes consciousness and memory are magical, separate souls inhabiting a body. Unconventional thinking posits that consciousness is the structure. If the sequence is replicated flawlessly down to the quantum level, your memories, your personality, your self-awareness remain perfectly intact.
So what does this all mean? We have gone on an incredible journey today. We started with an ant trapped on a twisted piece of paper. We watched winter flowers bloom on command. We questioned the certainty of quantum physics. And we just faxed a human being across the galaxy.
It's been a lot to process.
It really has. But as we wrap up, we have to return to that Möbius strip.
Yes, because the essay ends with a very stark, crucial warning. Creating the Möbius strip requires taking that flat paper and making a twist. But that twist must be exactly 180 degrees.
Right. Unconventional thinking isn't just chaotic rebellion. You don't just say crazy things and hope they work.
Exactly. If you twist the paper 179 degrees or 181 degrees, the ends don't align. The loop fails. The essay warns that a misaligned flip doesn't reveal the truth. It creates a perverse, distorted theory that can bring endless disaster.
It has to be perfect.
Yeah, unconventional thinking is a highly precise, deliberate key used to unlock reality. It requires rigorous logic applied in a completely novel direction.
And that is the ultimate toolkit for you to take away from this deep dive. When you're staring down an impossible problem at work or a completely gridlocked interpersonal conflict, do not accept the dead end.
The dead end is an illusion drawn by conventional thinking.
Exactly. The solution is there, but it requires you to precisely flip your perspective 180 degrees. You have to change the shape of the paper.
You have to question the address order of the entire problem.
Absolutely. Now, I want to leave you with one final provocative thought to mull over. It builds on what the essay said about the burden of knowledge, how the sheer volume of conventional data is exhausting our brightest minds before they even reach the frontier of discovery.
Right.
If carrying too much accepted conventional knowledge is actually the heavy gravity slowing humanity down, will the next massive evolutionary leap require us not to learn more, but to find a way to intentionally unlearn what we so confidently think we know?
That is a truly paradigm-shifting question.
Something to chew on as you go about your day. Thank you for joining us on this deep dive. We'll see you next time.